You hear the term AI thrown around everywhere, right? From your phone's navigation to the huge systems that power our industries. But what is it really? Today, we're going to break down the entire AI family tree, from the basics of machine learning all the way up to the massive foundation models that are changing, well, everything. Let's dive in.
So to really get a feel for what AI does, let's follow someone for a day. We're going to meet Thondi. She's a mining engineer, and her workday is the perfect showcase of how all these different kinds of AI actually work together out in the real world. Okay, so every morning, Thondi heads out to this huge, bustling mine site. And from the second she gets there, AI is kind of her invisible co-pilot, helping her work smarter, faster, and way, way safer. It's not just one tool. It's woven into pretty much everything she does.
I mean, just think about her toolkit for a second. One AI helps her get to the site, finding the fastest route and dodging traffic. Another one predicts when a massive haul truck might break down before it actually happens. Then there's this vision system, which is like a digital lookout, spotting safety hazards in real time. And at the end of a long day, a generative AI like ChatGPT helps her take all her messy notes and turn them into a perfect report.
So yeah, we call all of these tools AI, but they're obviously doing totally different jobs. One is predicting, one is recognizing, and one is literally creating something new. And that brings up a really important question. Are they all the same kind of intelligence? Figuring that out is the key to understanding this whole landscape.
All right, let's actually map this thing out. To really get what's going on with Thondi's toolkit, we need to look at AI's family tree. This is going to help us untangle all those buzzwords you hear. AI, machine learning, deep learning, and see how they all fit together. At the very, very top of the tree, you have artificial intelligence itself, AI. This is the big overarching concept, the main goal, building machines that can do things that normally require human smarts, like reasoning, learning from experience, and making decisions. It's the whole field. Now, tucked inside that giant AI bubble is machine learning, or ML. This isn't the goal, it's a way of achieving the goal. Instead of programmers writing out endless rules, we just feed the machine tons and tons of data and let it figure out the patterns on its own. Thondi's predictive maintenance tool? That's a perfect example. It learned what a failing truck looks like by analyzing data from thousands of them. And if we go one level deeper still, that's where we find deep learning. This is the real engine of modern AI. It uses these super complex structures called artificial neural networks, which, and this is wild, are designed to work a lot like the human brain. This lets them tackle incredibly complicated patterns, like recognizing a specific face in a video, or understanding the subtle meaning in a sentence.
So it's all about layers, right? All deep learning is a form of machine learning, and all machine learning is a form of AI. But it doesn't work the other way around. Here's the easiest way to think about it. AI is the entire workshop. Machine learning is your main set of hand tools. And deep learning? That's your specialized, heavy-duty power tool that you bring out for the really tough jobs.
And this chart really nails the difference in their objectives. The goal of AI is super broad. Hey, complete this complicated human task. But machine learning's goal is way more specific. Find the patterns in this giant pile of data. And honestly, that shift from a big idea to a specific method is what kicked off the whole AI explosion we're seeing today.
Okay, so we've said deep learning is the powerhouse. Let's look under the hood for a minute. What exactly is the engine that's driving these incredible systems? Well, it all comes down to something called the neural network. I know it sounds like science fiction, but the core idea is straight from biology. Our brains have billions of neurons that connect and send signals to each other. Well, an artificial neural network just mimics that with a system of interconnected digital nodes that pass information through a series of layers. So, let's just trace how it works. The input layer takes in the raw stuff, say all the pixels from a picture of a cat. Then the hidden layers get to work. The first layer might just spot simple things, like lines and edges. The next layer might combine those edges into shapes, like an ear or a whisker. Deeper and deeper layers assemble those features until they form the abstract idea of a cat. And finally, the output layer gives you the answer, yep, that's a cat. It's this layered, step-by-step analysis that makes deep learning so powerful.
Now, very recently, this technology took an absolutely massive leap forward. We went from AI that could only analyze stuff that already exists to AI that can generate brand new original content. This is what people are calling the generative revolution.
This is the big shift. Traditional AI, like Thondi's maintenance tool, looks at data and makes a prediction. it's an analyst. But generative AI, like her report assistant, learns the underlying patterns and then uses them to create something that has never existed before. It's really the difference between being a movie critic and being a movie director.
And this creative jump is being powered by something we call foundation models. What are they? They're just enormous, deep learning models, neural networks with billions, sometimes trillions of connections that have been pre-trained on an unbelievable amount of data, basically huge chunks of the internet. They're called foundation models because you can build all sorts of other applications like ChatGPT right on top of them.
And the growth here has been just explosive. Seriously. In just a handful of years, we went from models that were good at understanding the context of a sentence to these gigantic models with hundreds of billions of parameters, think of them like tiny learning knobs, that can write college-level essays, create stunning art, and even pass professional exams. The pace is absolutely breathtaking. So, with all of this incredible progress, where does today's AI actually fit into the grand scheme of things? It's a good time to take a step back and look at the bigger picture.
Researchers usually talk about 3 potential stages for AI. The first is artificial narrow intelligence, or ANI. This is where we are right now. Everything we have today, from Siri to the most advanced version of ChatGPT, is ANI. It might be brilliant, but it's brilliant at one single thing. The next step, which is still theoretical, is artificial general intelligence, or AGI. That's an AI that could learn and reason across many different areas, just like a person can. And way out on the horizon is the sci-fi idea of superintelligence. The key thing to remember is, for now, we are living firmly in the age of narrow AI.
And this brings us right back to Tandy. With all this context, she starts to see her daily toolkit in a whole new light. It's not just one big blob called AI, it's an ecosystem of different specialized intelligences. She has a narrow AI that predicts, a narrow AI that recognizes, and a generative form of narrow AI that creates. Each one is the absolute right tool for the right job.
So this whole journey leaves us with one last kind of mind-bending thought. We've managed to build machines that can learn from our past and create brand new things for our future. But even the most advanced AI today is really good at recognizing patterns, not at genuine understanding. The next great challenge isn't just about making AI bigger or faster. It's about bridging that gap between calculation and actual comprehension. And what happens when we do? Well, that's the question that's going to define the entire next chapter of AI.